Okay, so we use percent composition for one reason. It's used to find what part of the whole each element represents in a compound. So it lets us know like each part and how much that part is of the compound. So when I do this, it really ends up looking like this. Mass of element divided by molar mass of the compound times 100. And when I write the answer, I write it as a percent. So it tells us what percent of the whole each element is. And I'm going to show you the steps to work through one of them, and then you'll be able to use the ones that I've given you. So let's do an example. So you've got one in your notes. Let's use our, we've used this one before, aluminum sulfate. I think we've used it before. And I say to you, find the percent composition of each element. So the first thing I'm going to work with really is just like calculating the molar mass. So I'm going to bring down my elements, Al, S, and O. And then I'm going to write down, and I want you to go ahead and do this. Write down how many of each of those you have, and then we'll check it. So how many aluminiums do you have? How many sulfurs do you have? How many oxygens do you have in that whole compound? And then check and see if you have what I have. Okay, any questions about how I got those? All right, now I'm going to have you find the molar mass of each individual element. So go to your periodic table and find them. And then just stop. What you need? Periodic table?
Yeah.
Just go over there and grab one. There's some pink ones up top, I think. You guys, if you ever are missing your periodic table or need another one, I always have extra ones over there. Just take one. I refill it all the time. All right, so I think, is the atomic mass of aluminum 27?
Yep.
Okay, so this should be 27.0.
Mm-hmm.
Sulfur 32.1?
Yep.
Okay. And then this one would be 16. So now you're going to carry it out just like you did when we did molar mass. So I would take 2 times 27, which gives me 54.0 grams. 3 times 32.1, that would be what, 96.3. What's 12 times 16?
192.
Thank you. Okay, so now I'm going to add these guys together. Go ahead and do that, and then we'll check. Daniel, what'd you get? 342.3 grams. My total, right? Okay, so now what I do next would be to look at each part. Ooh, that's not good. So we're going to separate them. AL, S, and oxygen. And my AL was 54 grams. And my total was 342.3 grams times 100. My sulfur would be 96.3 over 342.3 times 100. And then my oxygen would be 192 grams over 342.3 times 100. So let's do the math and see what you get. Round to the tenth place. When you've got them all, stand up. What did you say? 10th place. Okay, find your lab partner, check your numbers. I guess you got it. What'd you get for aluminum? 15.8% aluminum. Rick, what'd you guys get for sulfur?
28.1%.
28.1% sulfur. And Maria, what'd you get for oxygen? 56? Yeah. Okay. Everybody pretty much agree with those? Yeah. If I wanted to check this and see if they were right, what could I do?
Add them up.
Add them up. Here's the range. If you have anything from 99.8 to about 100.2, then you're in acceptable range. Sometimes because of the way you round, you're a little under or a little over. So keep that in mind. Always check them. It will save you points on the quiz or test because someone in here will mess it up. It always happens. Every year it happens. So here's what we're going to do. We're going to finish up our molar math stuff. If you're waiting on a chemical, then start working on your homework. If you get all the chemicals done, stop, because I'm not done. When you get all of your data table done, you need to go through and highlight your molar masses in that column, just your numbers, and then you're going to submit it to Google Classroom. Yesterday's date, because that's when I posted the lab. When you get all that done, then you have the rest of the time for your homework, which is your percent composition stuff.